Hi everybody, I'm here to talk to you all today about two-way tables. A two-way table is a graphical representation of two categorical variables.
Two-way tables are drawn like so. This first row, we're going to have the probability of success of event B. Like so. In this row, you're going to have the probability of the failure of event B, represented by B not. This little C just means it's the opposite of this event happening. In this column, you're going to have the success of event A. And likewise, this column will be A not. Next, we'll fill the table with values normally given to you in the problem. I'm just going to put some random problems in there. Then, to find our marginal probabilities, we're going to add them up. Next, to find our table total, we're going to add up either the rows or the columns into this section here. And that is how you draw a two-way table.
You can use two-way tables to find many different things, such as conditional probabilities, which is the probability of a single event occurring given another event. You can use two-way tables to find joint probabilities, which is the probability of two events succeeding at the same time. You can also use two-way tables to find the frequency, which is the data inside of the two-way table. And there are two types of those, relative and cumulative, and we'll get to those two later. You can also use two-way tables to find marginal distributions, which is the successive event over the total of all the table.
Let's take a look at conditional probabilities. Remember, conditional probabilities are the probability of an event happening given that another one happens. For instance, we're going to set up the probability notation for the probability that we have an event A given the probability that event B fails. Represented as so. To find this, we're going to first look at A. Next, we need to remember that we're looking given that B naught takes place. We'll see that we have a total of 100 for B naught. So that will be our denominator. Then we look at the value where A takes place in B naught, which is 44. And that is our answer.
Alright, today we're going to show you guys how to find joint probabilities using two-way tables. Now, as you can see from the probability notation, we are looking for the probability of the success of event A and the success of event B. Now, probably the most important thing in this probability notation is the AND symbol. This symbol right here shows that we are looking for the success of two events at the same time in the data set. So, to find this, we would look for the success of event A and its intersection with the success of event B. So as you can see, the two intersect right here. Therefore, the probability of the event, finding the success of event A and event B is found as 12 over the total of the table, which is 143. Alright guys, we're going to show you another way to find joint probabilities using two-way tables. In this one, we're going to be looking at OR problems. So, in this example, we are finding the probability of the event A failure or the event failure of event B. So, another important symbol here is this symbol right here. This is the symbol for OR. which means we're looking for anywhere in the problem where either of those two occur. So, on this table, we will look and see all the areas where the OR is occurring, which is the event failure of event A or the event failure of event B. So we're going to find, so right here we can see event A, failure, and event failure A here. See B, the failing right here as well. So therefore we're going to take these three numbers and add them up. So in that we find that probability is 100 over the table total, which is 107.
Alright guys, I'm going to start off by telling you about frequencies. Frequencies are every point of data in the two-way table. Now, there are two kinds of frequencies. We're going to start off with frequency counts. The first thing to know about frequency counts is that they all add up to some cumulative value, shown here in the table total. Now, everything in the data has to add up to that. So we're going to go ahead and fill this in. 18 plus 9 equals 27. 27 plus 23 equals 50. It means we're on the right track. Next, we know that 9 plus something has to equal 16. We know that's 7. Then, we know that 23 minus 7 equals 16. And these two are going to add up to be 34. And 34 and 16 also add up to 50. So that's frequency counts. Over here, we have relative frequencies. And the thing to know about relative frequencies is that they have to add up to 1. So we have 0.4 plus 0.6 equals 1. 0.3 plus 0.1 equals 0.4. This is going to be 0.1, and this is 0.5. And once again, we see that both the columns and the rows add up to 1. And that is frequencies.